Give him a shoe back.
Shoes,
I like your shoes.
Those are nice shoes, Cole.
Where do you get those?
Alright, we're going to go get right to the lesson so that we can have lots of work done.
Yay.
So, 6.5 is what we're looking at today. We're going to continue to talk about logarithms. Guys, come on, get it together a little bit. I don't know who's making all the noise.
I didn't do it, but that's
Aaron. That was Aaron?
Yeah.
Oh, I'm sorry.
Come on, Aaron.
Well, typically this front row, 9 times out of 10. Just kidding, Aaron.
8.7.
You never do anything. So,
Sure,
we're
because
going to continue to talk about logarithms. But today we are looking at different, well, let's start here. What did we talk about yesterday with logarithms?
Transformation to
Yeah, we looked at how we can move the logarithms on a graph and how that changes our equation. Good. Today we're going to look at different properties of logarithms. So we're going to look at how we can expand logarithms, like rewrite them and expand them. Also how we can condense logarithms, to rewrite them in a form that is smaller, I guess. So here are the first couple properties of logarithms that we are going to look at. I think there are only 2 slides of notes and then some examples today. These 3 properties are ones that you're definitely going to want to have written down. So I'll give you a second to get those down and then we'll look at some. I think the first 2 properties come fairly naturally and are easy to remember. This third property isn't tricky, but maybe it's not as natural or we don't. Also, for the 6 people that took a picture of this slide, where else can you find these slides? Yeah. Not on Snapchat.
It's like a really good story highlight.
All of these properties are just different ways that we can write logarithms. So with the first one, product property. If we have, let's say, a log of 6, and inside that log we have 7 times 8. Like this property says, we can rewrite it as log of 6, or log base 6 of 7 plus log base 6 of 8. Right, so we keep the same base every time, yes? That is, yeah. Well, I mean, when it's log 6 of 7 times 8, we can just punch in our calculator, right? Figure out what that is. But you're right, the time where that's actually useful is being able to split that up. Yep. Quotient property.
Are you down bad, right?
We have log 6, let's say x over 9. We could rewrite it as log base 6 of x minus log base 6 9. So in the homework stuff today, if they give you something like this and they ask you to expand it, they'll ask you to rewrite it and to expand it, this is what I would expect to see. Just write it as other forms. Now, this power property we have talked about before, but I don't think we ever gave a property to it. But if we have log base 6, 5 to the x, you could rewrite it as x log base 6 times 5. That's all we're talking about there. Nothing Let's look at a couple of examples. These types of problems the textbook really likes, where you can't use a calculator, but they tell you that log base 2 of 3 is approximately something, log base 2 of 7 is approximately something. We have to evaluate each logarithm. So in each logarithm, in A, B, and C, we need to rewrite it so that we have log base 2 of 3 and log base 2 of 7, so that we can approximate what that logarithm would be. So if we look at letter A, we can rewrite this as log 2 of 3 minus log base 2 of 7. Now what we do next if we're trying to solve this, reevaluate. Yeah, we can fill in those numbers. So we have 1.585 minus. And we can subtract those and figure out, I don't know what that is in my head. I've written that somewhere. 1.222. We can subtract those and get the answer. I mean, if you want to check it, we can just plug this into our calculator, but they're trying to force us to use the rules, right? So the work that I would expect to see is right here. How about letter B? How would we want to rewrite that one? Say? Right, exactly. To kind of backtrack one step, and Faith did this but didn't explicitly say it. We could rewrite 21 as 3 times 7, and then we can split it up like this, just like Faith said. So she didn't say this step, but she obviously knew that we could do it because she went right here. So then instead of subtracting those two, we would add them. If someone can punch that in their calculator, that would be awesome. Anybody punch that in? I got it written down. I'll do it.
It's 4.39.
And then with this example, letter C, what would we split that 49 up to be? Yeah, 7 times 7. Log base 2, 7 times 7. We would go through the same. Questions on any of those? Now, in this case, they give us ln, right, the natural log. The same rules apply for natural logs as for logarithms. So that might be something that you just want to make a note of next to all those properties. But the same thing applies for ln. So we could rewrite this. This says expand. We could rewrite this as ln 5x to the 7 minus ln of y. Could we do anything else to expand this? No? What about here? This is 5 times x to the 7. Could we expand that? Nope. We'll get to that. We'll get to that, but there's something that we can do before that. Right? Since these are being multiplied inside the ln, we can split them up and add them.
Is that 5?
That is a 5.
Sorry, that was a 3.
Now, like Faith said, the last step that we can do is write this in front. So if they ask you in a homework question to expand that, you would need it to be completely expanded in this form right here. Questions? Are we feeling like this is pretty straightforward, or, I mean, this is very similar to what we've been doing for like this format of where I throw a bunch of rules at you, and these are the rules, and now we just need to apply these rules. And I think out of all the different types of rules that we've looked at, like compared to yesterday, I think these three rules are pretty simple, straightforward. Another thing they might ask you to do is to condense. So what is something we could do if we move left to right on this equation or expression? What could we do to condense that expression?
Could just like down into 3.
Well, I mean, when it says condense, it's not just simplify down to one number. When it says condense, it wants us to rewrite it in the smallest form possible. So you're right, we could technically punch that on our calculator and just get probably some decimal. Yeah, there.
Wouldn't it be like the log 9 minus log 3?
What did you say? Log what?
Log 9 minus log 3. Or is that correct?
So what we're looking, you're on the right track. What we're looking for you to do here, our rule said that if we have log 9 plus, it's actually, we can write it inside the same log as multiplication. So 9 times 2, and then where does this 3 go? How can we? Yeah, it's the power. 2 to the third. And then now if we look at this minus sign, what does that mean that we do when we write it inside the same log? We divide. So when it says condense, that is what it would be looking for you to do. Which, yeah, it's pretty good enough. But do we see where each of those come from? Why we can do 9 times 2 to the third? Does that make sense with the rules that we looked at?
Can you explain that? Like how the rules or all of that again?
So our rules said, we're kind of working the rule in reverse. I mean, the rule said that we can take m times n inside the logarithm and split it up as log of m plus log of n. They gave us this right here. So we started with them being added together. And we can condense them by putting them under the same logarithm. Here's maybe a little more clear example. I think that 3 up front might be confusing. So if we just had log 9 plus log of 2, we could rewrite that as log 9 times 2 inside the same log. Alright? Probably, yeah, if they just gave you this right here, we could simplify it just to 18. Now, like over here, you could simplify this, right? But I would accept it. I mean, on the answer key, you probably would see that right there. Okay? Because that shows me that you know where each step is. Are we good with those properties and those rules? I think once we practice them a little bit more. One, I think it's our only other rule. Yeah, sweet. One more rule. Our change of base formula. Now, what's here in the middle is important and definitely something that you want to write down. Probably the one that I would use a little bit more often would be this right here. So they kind of give us two different rules. We'll definitely have both of these down. And we'll talk about a few things with each one. The properties from the earlier slide talked about ways that we can condense and expand logarithms that are being added, subtracted, multiplied, or divided, right? This is giving us, I mean, the change of base formula gives us a way that we can just rewrite logarithm, just one logarithm. So there's not any operation that is happening right away. It's just one logarithm that we're rewriting. If we look at this top box, we have log base c, so log base something of a can equal, and now they introduce, this is where I could see some confusion, they introduce a new variable, they introduce b now. So we can choose, as long as those two logs on the top and bottom have the same base, then we're in good shape, and this is true. 99 out of 100 times, what do we want our base to be? 10. Yep. So that b value, they write it in there, but if I give you like log base 6 or 7, we could just rewrite it as log of 7 over log of 6. We don't write base 10, so base 10 is like our go-to. So we can write it as base 10, we'll do that. Something that I remember when we were rewriting this 6 is below the 7, so when we rewrite in our fraction, it stays on the bottom. So that's kind of something that's helpful. When we look at the second way to rewrite a logarithm, I mean, the same thing applies. The log base c, our base stays on the bottom, and this base stays on top. It's our numerator, but it's just the same thing as ln over ln. And this shouldn't surprise us, the second one, because remember, all ln is log base e of something. So it's sticking with the same rule. They both have base e, but we just rewrite that as ln. Let's see how we would apply this. Evaluate using common logarithms. So when it says evaluate, we would like us to rewrite it. So we could rewrite this as log of 8 over log 3. We also should rewrite it as ln of 8 over ln. You might be thinking, why is this helpful at all? Because we can just plug that base 3 in our calculator. Well, believe it or not, some calculators don't let you choose your base. Or sometimes when you're graphing, some calculators don't let you choose your base and your y equals. So you might need to rewrite the gap base. Nope, nope. Since it says evaluate using common logarithms, this would be the answer that I'm looking for. I think the directions would say evaluate using natural log if it wanted the second one. I was more just trying to point out the right. Yeah, there it is, natural log. That's the last one. Yeah. Questions? Last one. I have 2 different slides of 2, 4, 6, 8 problems. I'd like you to work with a partner. Write your answers down on paper, and once I see you and your partner only need one piece of paper. Once you and your partner come up and show me the 8 problems all finished, then you'll get the worksheet. You're good to go if you would like.
Okay, I'll look at it.